What's up, everybody? Welcome to my premiere video on Scappy math. Today, I want to do some differential equations, actually. I've been getting into these. I took this class a long time when I first got into math at a community college, and I never really got back into it until recently. I just did the 1 year of it, a couple semesters worth, but I'm going to do a differential equation today that has a lot of like algebraic elements in it, in terms of like algebra 1. Like you'll see some trends. So let's get started. So what I want to do is I want to solve this differential equation. So we got the second derivative of y plus 2 times the first derivative of y minus 8y equals 0. I usually call these y double prime and y prime. And we have some initial conditions as well. So we do know that y of 0 will equal 1, and y prime of 0 is going to equal 10. So we're trying to figure out what we want to do ultimately is find just y. So that's our goal for today. Okay, so let's try it. So with these, you can see like this format looks very familiar. If these were x, if this was x, if this was x squared and this was x and this was just a constant, it would look like a trinomial. And eventually it's going to turn out to be that way. So what we're going to do is, our first step is we're going to assume that y equals e to the rx, where r is just some constant. And r doesn't have to be a real number either. It can be an imaginary number. It can be a complex number, imaginary number. But we're going to assume that y is in this form. Okay. And you're probably like, well, why did you do that? Well, we'll figure it out. Like when we get more into the problem, we're going to see how that kind of coalesces with everything else. So what we'll do is we'll find the first derivative of y. So we'll say y prime equals, now since r is a constant, if you take the derivative of this, it's just all we got to do is bring down this constant. So this will just be r times e to the rx. Okay. And then what we're going to do is we'll find the second derivative. And we do the same thing. Again, r is a constant. So, and r is a constant here. So when we take the derivative of e to the rx, it would just be r times e to the rx, but that r gets multiplied by the r out front, and we have r squared e to the rx. Okay, so we have these three equations that we're eventually going to use here in a second, and we'll do it right now. So what we're going to do is we're going to put these substitutions back into this original differential equation and see what we get. So let's do it. So we know that y double prime equals r squared e to the rx, and then we have plus 2 times y prime, which is going to be r e to the rx. I really didn't need parentheses, but I'll keep it there. And then we have minus 8 times y, and that's just e to the rx, and that all equals 0. Okay, cool. So what we can see is in this expression on the left-hand side, we can factor out an e to the rx. And so let's do that. Okay, so we factor out e to rx. What's left? Well, if I factor out of here, I get r squared. If I factor it from here, I get plus 2, and that would be r. And then from here, I just get minus 8, and that equals 0. And this is what I was explaining before, where if you look at this expression right here, it looks a lot like a trinomial, doesn't it? Just something you might see in algebra. What we can do here is we can actually divide both sides by e to the rx. And the reason why we can do this is because e to the rx, no matter what it is, it will never equal 0. So there's nothing I can raise e to, no real number I can raise e to and get 0. So kind of nice there. We can just actually go ahead and, these don't cancel really, but this is just 0. So we can go ahead and divide both sides by e to the rx. And so what we're left with is r squared plus 2r minus 8. And then obviously 0 divided by e to the rx is still just 0. Okay, cool. So now we have a trinomial, and what you're more inclined to do is just to go ahead and factor this. So we need two numbers that are going to multiply to give me -8 and then add to give me +2. So it's going to be the product of two binomials. I have an r squared, so I need an r here and an r here. And what we're going to have is r plus 4 and r minus 2. And this will work. If you actually went ahead and foiled this or did the box method on this, you would get this expression back. So it looks pretty good. So now what we're going to do is we're going to set both factors equal to 0, and then we'll solve. So I'll be pretty thorough with this, but so we'll get r equals -4 here. And if we add 2 to that side, we get r equals 2. So we have these r values. Okay, now what? Well, we don't just put them back here per se. What's going to happen with this is when you have two unique roots like we do now, two unique real roots, -4 and 2, there's going to be what's called a characteristic equation that you can use. And it's going to be characteristic of the solution to this problem. We're trying to find y. So what we can say is that we know that the solution will be in this form. It will be C1, which is just some constant, times e to the r1x, and I should probably label these r1 and r2, plus C2 times e to the r2x. Okay, so that's going to be our general format for the solution to this problem. Okay, so where do we go from here? Well, we know that we're going to use these original conditions to kind of figure out what C1 and C2 are. Okay, we do know that y of 0 equals 1, and we can use it right here. So what we would do is everywhere we see an x, we would put a 0. We do know that r1 is -4, so that's -4, but that's times 0, plus C2 times e to the r2. R2 is 2, and then x is 0. And we know that when we do this, we get 1. Okay? So 0 times anything is 0, and then e to the 0 is just 1. So this would just be 1 times C1, which is, well, just C1, right? And then we have e to the 2 times 0. 2 times 0 is 0, and then e to the 0 is 1, so this would just be C2. Okay, cool. So what happens is we do have an equation here that's going to provide some insight as to what C1 and C2 are. Granted, it's just one equation. We can't do anything with it now. This has infinite solutions. But what we're going to do is we're going to come up and use this guy right here to figure out another equation that involves C1 and C2. Okay, so I'm going to do that right now, and we just got to remember what we had. Okay, so if we come back here, we know that y double prime 0 equals 10. So let me just write that up here so we know. Okay, our characteristic equation is this. I'll just rewrite it up here. And then we had our two roots like that. And so now what we got to do is, since this is y double prime, or the first derivative of y, we need to find the first derivative of this equation. So let's figure out what y prime would be, okay? Now this is nice because C1 is a constant. And when we take the derivative of e to the -4x, it's just going to be -4 times e to the -4x. I'll bring the -4 out front so it looks like this. Okay, just in front of the C1. Okay, then I'll do the same here. The derivative of e to the 2x is just 2e to the 2x, and I'll bring the 2 out front, so it'll be 2 times C2 e to the 2x, okay? So this is kind of nice because now I have the first derivative, and I can use this original equation to get some insight as to what C1 and C2 will be for this So let's try it. Okay. We're going to put in 0 wherever we see an x. So we got negative 4 c1 e to the negative 4 times 0 plus 2 c2 e to the 2 times 0. And we know that when we do this, we get 10. So this should be equal to 10. Okay. Negative 4 times 0 is just 0. E to the 0 is just 1. So we're going to get 10 equals negative 4 c1. Same thing here. 2 times 0 is 0. E to the 0 is 1. So we just get plus 2c2. Okay. And we got something that looks kind of nice here. Okay. So we have another equation right here. Okay, great. So what we're going to do is, if you remember the first equation, it was this. It was C1 plus C2 equals 1. Okay. So now we have a nice system of equations that we can use to definitively find C1 and C2. You can use elimination here. You can use substitution. I'm just going to use substitution. I'm going to take this equation here and I'm going to just subtract C2 from both sides. So I'm going to get C1 equals 1 minus C2. And then wherever I see a C1 in this equation, I'm going to substitute in this expression. So now I'm going to come over here too. So I got 10 equals negative 4 times C1, but I'm going to substitute 1 minus C2 in. And then I got plus 2C2. Okay, great. So now this is just some basic algebra, really. We got 10 equals, I'm going to use the distributive property here. Negative 4 times 1 is negative 4. Negative 4 times negative C2 is positive 4C2 plus 2C2. Okay. I'll do two things at once. I'm going to add 4 to both sides, but then I'm going to actually just combine like terms here. 4C2 plus 2C2 is just 2C2. And then over here, this cancels. This will be equal to 14. Okay. And then our last step would just be to divide both sides by 6. I'm going to bring the C2 over here. 14 over 6 is just, if we were to simplify, it would just be 7 over 3. So we got 7 over 3 there. Great. So now we know C2. Now we're just going to go find C1. So we're just going to put it back into this equation right here, and we should be okay. So let's do it. C1 equals 1 minus C2, but C2 is 7 over 3, or 7/3. And 1 minus 7/3, well, 1 is 3/3. So 3/3 minus 7/3 is negative 4/3. Okay, and then we found our C1. So what we did is, excuse me, what we did is we now have our solution. We now found y. We're actually done here because we know C1, we know C2. Let me box this. And we can put it back into our characteristic equation. So we got y equals C1, which is negative 4/3, times e to the negative 4x, plus 7/3 e to the 2x. Okay, and we did it. We found y. So that's our y. Now you're thinking, okay, you found it. Is that the right answer? Well, like with any math problem, it's good to have a check, right? And we can do a check here. And we will. So this is why, like, we found it. This is a bona fide solution. Let's check it though. Let's make sure we did it right. Okay. Now, if you remember, it should jive, so to speak, with the original one we had, which was this. Okay. So this should hold true here. Okay. Now we know what y is. Y is right there, so it would go there. But like, what about these guys? Well, what we're gonna have to do is we're gonna have to take the first derivative of this. Okay, so let's find. We have this. We know this is our equation that we're trying to check. Let's find y prime, or the first derivative of y. Okay, so we got to come up here again. This is a constant, and then when you take the derivative of e to the negative 4x, you'll just get negative 4 times e to the negative 4x. And then that'll be multiplied by this. Negative 4 times negative 4/3 is positive 16 over 3. Okay? We do the same thing here. The derivative of this would be 2 e to the 2x, but the 2 times the 7/3 would just give you plus 14/3. Okay, and we did it. We found the first derivative. Okay, not done yet, but we got to find the second derivative, so let's do that. So let's do second derivative of y. So let's take the derivative of this once again. And so we got e to the negative 4x. This would be negative 4 times e to the negative 4x. The negative 4 comes out front, so that'd be negative 64 thirds e to the negative 4x. E to the 2x will be 2 to e to the 2x. The 2 comes out front, so this would just be 28 over 3 e to the 2x. Okay, and that wasn't too bad either, to be honest with you. Okay, so now we have our y, we have the first derivative of y, and we have the second derivative of y. And we can go ahead and put that in to our equation, to this guy right here, and see if it holds true. So let's do it. So we got y double prime, or second derivative of y, however you want to say it, is negative 64 over 3 e to the negative 4x plus 28 over 3 e to the 2x, okay, plus 2 times the second derivative of y, which is right here, which is going to be 16 over 3 e to the negative 4x plus 14 over 3 e to the 2x, okay? And then finally, I'm going to have to put it right here, minus 8 times y, which is up here, if you remember. So that's negative 4 thirds e to the negative 4x plus 7 thirds e to the 2x. All right, so let's see what we got here. So hopefully you guys can see this on the screen. I think you can. So it's negative 64 over 3 e to the negative 4x plus 28 over 3 e to the 2x, okay? We'll do the distributive property here. So we're going to get plus 32 over 3 e to the negative 4x. And then this will be 2 times 14 over 3 plus 28 over 3 e to the 2x, okay? Then I'll try to get this in here too because I'm running out of space, but negative 8 times negative 4 thirds will just be plus 32 over 3 e to the negative 4x. And then finally, negative 8 times 7 thirds is actually minus 56 over 3 e to the 3, or e to the 2x, my bad, not 3x. Okay, now hopefully you can see this. It's getting a little toward the bottom, but if you look at it, we have like terms here, right here, and right here. Well, negative 64 thirds plus 32 thirds is negative 32 thirds, and then plus another 32 thirds e to the negative 4x would just be 0. So these actually, all these terms just cancel out. So it's 0. Okay, that's nice. That's kind of what we were hoping, right? Because we want a 0 here. Let's look at the e to the 2x terms, which are right here, here, and here. Sorry, that looks like a 3, but that's really a 2. So I got 28 over 3 e to the 2x plus 28 over 3 e to the 2x. That's 56 over 3 to the e to the 2x. But then minus 56 over 3 e to the 2x. So guess what? Those cancel out too, right? And I'm left with 0. So it actually turned out really nice. This all just kind of cancels out and then equals 0, which means that our check held, right? It means that this y, this equation we got for y, or this expression we got for y, is actually the correct answer, okay? So we went through the whole process. We did a check. Apologize, it got kind of a little hairy down here, but hopefully you can see that it's 0. And that's how you would solve a differential equation of this sort. So what we're going to do is, if we go back in another video, there's going to be different characteristic equations based on your answers for your roots. For example, if I had got a trinomial that gave me two of the same answers, so like say I had like R1 equals 5 and R2 equals 5, it's going to be a different characteristic equation, okay? There's also a chance that you'll get a complex number, okay? So I might get like R1 equals positive or negative 2i. In that case, there's going to be a different characteristic equation for that too. And so I'll do that in another video. Thank you for watching.